Hey guys, welcome back to AlgoYogi. We are now doing stack series, and our very first problem of the medium level stack problem is min stack. It's a really popular problem on LeetCode. I would say one of the oldest stack problems. It's a design problem where we will be designing a min stack class that will have a couple of functions, and along with the regular functions of a stack, which is push, pop, top, we will have this extra function called getMin, which we will use to retrieve the minimum element in this stack. All right, so let's go into it. I think it's a really interesting and easy problem, I would say. So regular functions, we will be having basically our stack, which in our case, we can just have a regular array to implement the stack, and let's go about designing all these implementing all these functions. So first thing first, push operation would be just a normal pushing the elements. Let's say if we want to push some values, and those values I want to define here. Those values could be, let's say we have 0, 1, -2, -3, 4, etc. All right, these are the value that we want to push. So in regular stack operations, we will be basically pushing the values onto our stack just like this, -3 and 4. So this is the top of the stack, not P, top of the stack. So we can access the top, we can pop the values, we can pop these values. Top will be -3 now. How about this special function called getMin? This is where things get tricky. This is the function that will make us think that how differently we should be implementing our solution, so that at every point of time we should be able to retrieve minimum value from our stack in big O of one time complexity. We don't want to go over the entire stack to check what is the minimum value out of these. Let's say this is -3. All right, this is the answer. We have to do it in big of basically constant time. So in order to do that, what we're going to do is, instead of just saving the value, we will start saving the minimum value at that particular step into our stack. So I would say when we have our stack right here, when I have my stack, so along with when I push the value, when I'm like pushing the values to my stack, I will have to basically I'll push a tuple, right? I'll push a tuple so that I can access the value and also its minimum in the stack at that particular position. So let's say if I'm pushing 0, so I will see what is the minimum at this point. So you can see there is no value in a stack so far, so 0 will be our current minimum, and this is the top of the stack. If you want to retrieve top, so you can return this value. This is the top of the stack, and if you want to return getMin, then 0 is the getMin right now. All right, so how about you have next value to push in, which is 1. So what I'll do at this position, when I'm pushing next value, so I'll push 1, but then I'll also calculate what is my current minimum right now, so that my getMin can access that value and retrieve that value in big of one time complexity. So at this position, I will see what is minimum between my current value, which is 1. So this is my current val, and what is the minimum so far, like in the last position, at the last position, which is right here. This is my last position. So I haven't pushed this thing yet. So my last min was 0. All right. So what is minimum here? 0. So I will push 0 over here, and this is the top of my stack right now. All right, this is no longer the top of my stack. All right, so now how about when I'm trying to push -2, and we will try popping the values as well. Okay, so I'll push the value -2. How about what's the minimum right now? So we're going to decide what is the minimum between the last minimum, which is 0, and the current value is -2. So -2 is the current minimum, and now top of the stack is right here. So how about we want to pop some values? So I'll pop this off, I'll pop this value off, and remember, everything will remain intact in terms of having top will move to this particular value, and here we have our value as 1, which was pushed over here. 2 is gone, -2 is gone, -2 is gone, and now my minimum also is 0. All right, then we can again keep pushing our values, and every point we are updating our stack. So we can push, we can pop, we can find the top, which will return basically the first element if we're trying to return the top first element, and then getMin also has access to the minimum value right over here at every single position at the top of the stack. All right, I think this is really clear. Some people try to implement this solution using 2 stacks, perfectly fine, but I thought we can definitely do it using 1 stack, just instead of saving values in one and the minimum in another stack, just have both of them together, right, man? Just that's gonna save us some space. We don't have to have like 2 reference stacks or list, whatever you guys want to call it, and do it that way. This would be much easier. All right, so let's implement our solution. It's going to be super easy, super straightforward, just like a regular stack. We're going to have our self.stack as like a list. That's how it works. I'm going to copy this. How do we push values into self.stack.append? What are we appending? A tuple. First thing first, what are we appending? The value. Next thing will be minimum for accessing the min stack. Minimum of what? Minimum of the value, current value, or let's check on the top of the stack. So stack -1, it's second value if stack exists, else we will just have value as value. All right, I think this is straightforward. Sometimes it might happen the stack is empty, so let's say we are pushing the first value into our stack, then that current value will be the minimum as well. It will be the value and also the minimum. All right, then popping, super easy. And they have told us, I'm gonna tell you guys, like they told us right here that all these operations, pop, top, getMin operations, will always be called on non-empty stacks. So we don't have to worry about checking the constraints if there is value or not. So these are valid operations. So we will return, or we don't return actually. We just this is a, it returns none. So we just from self.stack will just pop. We're using just pop, or we could just delete that value. I think this is fine. I think most important thing is just having this min function, getMin function. How about the top of the stack? We have to return a value which will be from the top of the stack. The last value, its value, it's at 0th index. Second is minimum. All right, now this is where we return. This is where we return the second, which is the minimum. Right, this is the minimum. And when we are popping basically the entire value and the minimum at that particular position. This is super simple solution. I'm gonna zoom out, and I think you are able to see the entire solution right here. Voila, let's submit it. I think, okay, there is one thing, very little problem. I think the self keyword I forgot. All right, dot. I think now we're good. Now we are super good. We are super good. Okay, I'm gonna submit it, and bang, bang. All right, and everything is happening in I would say a big of one-time complexity. That's super quick, super efficient, 89%. Let me see if I can get 100. No, okay, never mind. So first medium problem stack done. See you guys in the next problem. Ba, 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 ba.